recording. Okay, last class, we discussed more about secure coding standard, okay? And we discussed a couple of sub-rules for Rule 6 regarding methods. So let's see. Last class, I remember we already finished sub-rule 6, okay. And then next, let's take a look at the 7, sub-rule 7. Sub-rule 7, what it says is, do not declare a class method that hides a method declared in a superclass or interface. Okay, so what does that mean? Let's take a look at the example, okay. So this is non-compliant code. So we have a class called grant access, and this is a class method. So this class method called display account status. So it's pretty simple, just to do some print out. And then here we have grant user access. Okay, and here it extends. So it's inherit from grant access. And it also has a class method called display account status. Be careful here, okay, we didn't add that annotation override. So it's missing that part, okay? So be careful. Then let's see. In the driver, so this is a driver, we have a method called choose. So what this method here, within this method, we have two variables. This two variable type are grant access. Okay, grant access. And the first one is initialized to grant access to superclass. The second one is subclass. Okay, and then says if this username is admin, then it's going to display grant access display account. Otherwise, it's going to display subclass the account status. Then over here to pass in as user. Okay, pass in user, then it is not admin. Is it? It's not a, so it will go to this else. Is it? It will go to else. And but over here it says the output will be what? The output will be account detail for admin. So it will output this part instead of the subclass. So here is a dilemma part. Is it you pass in user, so it should go to this user one. Is it the user one, the user, if we take a look here, is it the type is superclass and the object is subclass. Okay, but looks like it call this method call this method. Is it? So the problem here is because over here, it didn't provide, so not provide overriding. Okay, not provide overriding, that will use the superclass. So that's a problem here, okay? Because this is a class method. So when we design inheritance, make sure, okay, if you have a subclass and the method, then you better provide an override method. And also over here, we change the method from class method to instance method. Okay, so whenever you design class, make sure, consider it beforehand, it should be designed as a class method or instance method. Instance method, it's associated with objects. Okay, with objects. Then this is a subclass, and you want this method override superclasses. Then you need to make this clear. Okay, make this clear. And after we rewrite like this, then this will perform as what we expected. Okay, so just be careful here. Okay, and then what is the next one? Discuss. Number 8, it discuss regarding preserve the equity contract when we overriding the equals method. Okay, so be careful, this equals method. And also, if you recall, equals is to check if contents are the same. Okay, so not regarding reference. Okay, so be careful here. So what does it mean? Equity contract. Okay, so here it gives the contract. There are 5 requirements. So first, it must reflexive. So reflexive means for any reference, x dot equals x must return true. Okay, the second one is symmetric. So symmetric means x dot equals y must also be returned true. Then y dot equals x must return true. Okay, the third one is transitive. So transitive is the 3 reference. So x dot equals y and y dot equals z, then must lead to x dot equals z. Okay. And also it must be consistent. Okay, so consistent means any reference of x, y. Then multiple invocation must be consistently return true or false. Okay. And also for any non-null reference, x that equals null must return false. Okay, so all of this are regarding the equalities contract. So let's see the example. The first example is regarding the symmetry. Okay, So here we define a class. This class is a final class. That means no subclass is allowed. It's called case sensitive string, and it just has a single instance as. So anyway, so this is a constructor. So it just does something, okay? And then over here, it overrides that equals method. That the equals is from superclass object. Okay, so what over here is that, okay, if the parameter is a class, that is a class, then it just call strings equal, but ignore case. Okay, so this is strings equals ignore case method. And then you cast this, this object, then you access its string instance variable. Is it? So that is a case of this object. And if object is string, then it's just called strings. Okay, and then you cast that object to string. Otherwise, if it is not either of these two cases, then you return false. Okay, so that's what this class is about for that equals. Then in main here to create an object of that case insensitive string object. Okay, and here you have a string Java, and this is also Java. Is it? Then I said, okay, I'm going to call CIS dot equals as. Is this going to be true? Yes, this is going to return true. Is it? Return true. But you will see when you call s dot, but this s is strings. And you plug in with this CIS. And based on strings equals definition, this is going to return false. So that means your equals definition violate the symmetry rule. Is it? So contract. So that's not right. Okay. So this equals method is not written correctly. So what you should write is you should do just return if it is an instance of that object. Okay. Plus the and this condition. Okay. So if you rewrite like this, then this will be symmetry. Is it? Because when you plug in a string and string is not an instance of this, so this is false. So even though this is true, but this is false, so it's still false. So that's why this is false. And when you do this, this is false. So that is correct. Okay, so this means whenever we override the equals method, we need to be careful, okay, preserve the equality contract. So that's rule 8. Then next, let's see, rule 9. Rule 9, the hash code we haven't learned. So let's just, because that's going to be in CS300, we are going to discuss this. So temporarily, let's just skip this, okay. Then let's take a look, number 10, okay. Number 10 is regarding the compare to method. Compare to, if you recall, is regarding comparable interface. Quite useful, as it, and also remember that a comparator, okay, interface. Okay, so same thing, whenever you implement a comparable interface, you also need to follow general contract, okay? So what does this general contract mean? So general contract, it has a couple of requirements, okay? It's that you must ensure the sign of this and this, okay? Must ensure this, okay? And then you must also ensure the transitive. Transitive means x greater than y, y greater than z, then x must greater than z. Okay, so this is called transitive. And what the next one is if x and y are the same. And then if you do X compare with another reference, and Y also compare with another object for another reference, is it? Then this must also be true, okay? This must also be true. And the last one is just that it's recommended, but not strictly required. Okay, not strictly, it's when X and Y are the same, okay? This is just for compare. And this is the equals. We are supposed to, this strictly, you should make this too, but it's not strictly required. Here is what it means, okay? So compare to and equals. And here it just gave an example, okay? And if you are interested after class, you can read about it. It's also pretty straightforward, okay? And then let's see what the next one, 11 is, okay? The 11 key used, because we haven't learned the hash map, that's going to be CS300 material, okay? So let's temporarily stop here for the method part. So method one, we already covered object orientation, the method, that this two one we come up. We already discussed. Next, let's do the miscellaneous first, okay, to see what's the interesting rules we have. Some rules, the first one, this is not the very first, okay, this is the second one. Related to what we, based on our knowledge, is do not use an empty infinite loop. So this is kind of common sense, is that try not to do this, okay, because that's an infinite loop, is it? And because we haven't learned threading, multi-threading programming, okay, so later on, after you learn threading, thread program, that may make more sense, okay. The next one, let's move to number 3. Number 3, it says, do not hard code sensitive information. Sensitive information means like username, password, user account, something like this, or IP address, something. Okay, so here it shows us an example. Okay, so this is a class called IP address. That then you just hard code. So this is not good. You shouldn't directly do that. Okay, so because what it says is some malicious user can use this command. Okay, says to deassemble the class and find the IP address, server IP address. A lot of time you want to protect server IP address. Is it? So here it shows how can it attack. Is it? And what it recommend compilant solution is, so the IP address, you can store it in a character array. Okay, character array. And then you can do the file handling. So you can read it from some file. Okay, because if you read from some file and you can then set some further protection. Okay, and then you get the IP address. Okay, so that's what it's recommended. And same thing that for the password, that we shouldn't have hard coded. Okay, so this is non-compliant. Okay, you want to establish a connection with the database, SQL connection, because whenever you want to query SQL database, you first need to establish connection. And normally database is user and password protected. Is it? So you don't want the password be exposed. Is it? So if you write, normally this is backend API. Is it? If you write some API, then you explicitly code the password username. That's going to be a problem. Okay, so that's not recommend. So what to recommend is then you try to store username password as some instance variable. Then you provide some method to get username password, and then you plug in it to the get connection. Okay, so the configuration file, it can be stored in some secured directory. Okay, so not everyone can get it. Okay, and maybe you can also encrypt it and decrypt it. So you can add more secured layers. Okay, so that's regarding sensitive information. We shouldn't hard code it. Okay, what the next one try to show is do not leak memory. Okay, so over here, what we said is about heap memory. Okay, so let's see over here. Is it? So here you define a class called lick. What's inside this class? It's a variable, is it? And this is a class variable. And the type is a vector, so it's some collection. And you create an object on heap. So this is vector. Is it? This is vector. Okay, then you try to use act. Use that. When you use that, you say, okay, I want to have certain number of cells. Is it? So each time when you do this act, basically it will create a new cell. Is it? It's going to point to. And then it's going to add So each time when you do add like 100, 200, it's going to create a new memory cell, is it? And then get them connected to this vector. That's how it works. Okay, and so this part, you allocate memory. Is it? You allocate memory. And then for this loop, you try to free memory. We call remove. Is it? So vectors remove method can also clear the memory. That's what it's try to do. But when you try to do, you do count -1 because greater than 0. You start from the last one all the way to the second first. Is it not the first one? So you still have this one in the hip. Is it? If you still have this one in the hip, then just think about this scenario. This loop, it can take, because it's always true, is it? It's kind of can iterate forever. If it's try to iterate forever, and then even though you just add 1, is it? But that memory cell, so it's always, so here is the heap. Is it? So you are going to keep asking. So keep asking for new memory to store that number 1. Is it? So eventually it will run out of memory. Because when you do the remove, you didn't free that 1. Okay, so this will cause memory leak. That's what we call memory leak. You keep asking memory, but you never release it back, okay? So this is an issue. So the compliant solution is when you do the remove, don't forget, you need to remove all of that, okay? Or for vector, so that's a better solution is we do try-catch block. You just call clear. So collections, clear method can also, it's going to remove all elements, okay, all of them, okay? So be careful here. And then what next one try to show is regarding memory leak is non-local instance field. Okay, so here we have a class called store, and this is some instance variable. Okay, so anyway, it's a reference type. And we don't need to also, anyway, this is some collection, some Java collection, data structure. Okay, then you call do something, so you're going to add something. Okay, so over here, it's regarding instance variable, and you're going to add something here, is it? And basically what you try to do is, you just try to do something, you just try to use a data structure inside a method. If it's inside a method, you should create, you should declare it as a local variable in a method instead of a class, instead of an instance variable. So after we learn class, don't put it just everything as instance variable, okay? So it says we should reduce the scope. So you can just do something, and you make this method or this variable. So make the variable as local variable to a method. When you make a local variable to the method, its scope is within the method. Okay, so within when the method, when it runs to the end of the method, then that variable is gone. Okay, so that we won't have memory leak problem. Okay. So that's also a suggestion. Okay, so don't, unless, so previous we learned instance variable. And the instance variable is for a class. It's for class, basically it represents an attribute for a class. So if it is not part of the attributes of a class, then you shouldn't do that. Here the purpose for this variable is just purely within this method. Outside of the method, it doesn't have any usage. Okay, so you shouldn't put it as an instance variable. Okay, because then in this case, toward the end of this method, garbage collection can clear the memory, can take care of this object. Okay, so it won't cause memory leak problem. So that's regarding this one. And what the next one try to show about miscellaneous, do not exhaust heap memory. So memory leak, we already discussed, infinite loop, etc. And also limited amount of default heap memory available. Okay. And so that's regarding some error may result of this, is it? And incorrect implementation of common data structure like a vector. Is it like previously we showed, okay? And also if you write a large number of objects to some string, output string, that can also cause a problem. Okay, so we needed to be careful, okay, here. So like over here it shows, is it? So for this class, okay, it's mostly going to deal with a lot of names and with file input. Is it? With file input, then here you have this add names. For this add name, then you have a while loop. Is it? While name. And then you're just going to keep doing. Is it? Then this can cause problem. Okay. This can cause problem because like the buffer reader. Okay, it's a buffer, so it has also certain restriction. Okay, so what recommend is you also first need to determine the file size limitation. Okay, file size limitation. And if the file size, if your file size is greater than the limitation, then you should give some exception. Okay, You shouldn't continue. Otherwise, you can continue. Or what you can do is you can also set the limit. Is it the line length limit and the line content limit? Okay, so because for input stream, okay, and output stream, we need to be careful about the limitation, the size limitation. Okay, it cannot go to too big. Okay. So that's regarding heap memory. There are more it's discussing about because it involves some other concept that we haven't learned, so we are not going to look at this point. The next one is regarding data structure. Okay, so collection. So here's a do not modify underlying collection. Okay, when an iteration is in progress. So previously, when we discuss for each loop, we discuss the concept. That's why we have the iterator method and the iterator concept for loop. Okay. So here, let's see. So in this example, so you have an array list. So that's pretty straightforward. We do use iterator. We do use has next and next, etc. But it says, okay, if I found something I want to remove, and here is a problem. So here, this remove is lists remove. Okay, not iterators. But here you use iterators. Those two are related with iterators. Is it? So that's not going to work. So this is going to cause a problem. Okay, so the compliant solution, so we need to be very careful in the future, okay? Then you need to use iterators remove. Okay, use iterators remove. Okay, so always keep this in mind. Otherwise, it can cause problem. Multi-threading, we haven't learned. Okay, thread safety. And what next one? Oh, that is just about the compliant solution. Multi-threading, we haven't learned, so we don't need to worry about that. And then what next? So all of the remaining parts we cannot discuss at this point because the concept we haven't learned yet. Okay. Okay, so I think let's just stop